have many names for these 7 basic quality tools. And the old 7, the first 7, the basic 7. This was first emphasized by Kaoru Esukawa, a professor of engineering at Tokyo University and the father of quality circles. According to him, as much as 95% of quality-related problems in the factory can be solved with 7 fundamental quantitative tools. The basic 7 quality tools are the tool for problem solving, situation tracking, as well as monitoring and analyzing the data. The 7 basic quality tools, also known as the 7 QC tools, oriented in the Japan when the country become undergone major quality revolution, had become a major mandatory topic as part of Japanese industrial training program. These tools were comprised of simple graphical and statistical technique, were helpful to solving critical problem related to issue. As told, I have to less use the Gujarati by Jayen sir, so I'll try to use the very fundamental language so everybody can understand, and I'll use some Hindi words during the topics. These 7 basically tools could be implemented by any person with very basic training in statistics and well simply to solve quality related complex issue. These tools are used in the Six Sigma, DMIC methodology, in continuous improvement, PDCA cycle, and lean management, removing waste from the process. We have the 3 modules of this training program. One we are going to do today is a very introduction module, which is of an hour. 45 minutes we're going to cover the session, and then 15 minutes for question and answer. And then we have other 2 modules, 1-day training, full-day training program, and 2 days workshop on the same topic. So now let's start today's session.
Okay.
Yeah. As I mentioned, 7 quality tools are the main means for collecting data, analyzing data, identifying root cause, and measuring the results. These tools are related to numerical data processing. Here, I would like to mention that these tools will not develop the solution. Solution we need to develop by ourselves, and implementation we need to implement by ourselves. So these quality tools, ये quality tools हमको collection of data में काम आएगा, analyzing of data में काम आएगा, root cause identification में काम आएगा, and result measurement के लिए काम आएगा. लेकिन solution provide नहीं करेगा. Solution हमको खुद solution define करना है based on the problem definition, based on the data and analysis of data. Solution हमको develop करना है और वो solution को implement भी हमको करना है. तो ये tool हमको help करेगा to reach to the solution and to reach to the method to implement the solution. These are the basic quality tools: Pareto diagram, stratification, scatter diagram, cause and effect diagram, histogram, check sheet, and control chart. I'll cover in today's introduction topic about each of these tools and where it is uses, how it can be used, and what are the benefit we are getting. So Pareto diagram, sometime हम उसको 80-20 rule भी कहते हैं. ये जो Pareto diagram है, combination of 2 graph, bar and line graph. Bar graph is related to the problem or defect or mechanical failure or component of customer complaint. It's divided in a smaller group of cause, like the cause of the or phenomena. An example, the number of occurrence, amount of money involved, and all those things. And the line chart is related to the cumulative effect of that. So as mentioned, this 80-20, like 80% of the problem or 80% of the occurrence defect is occurrence due to the 20% of the defect. So this is called 80-20. So 80% of effect, if we cumulate this graph here, and the 80% of the defect found is due to the 20% of the cause. So it will use for the identifying the problem, the prioritizing the problem, to identify the cause of the problem, and to review the effect of action to be taken. ये जो review करने के लिए बाद में, suppose initially हम लोग जो use करते हैं Pareto diagram to identify the problem, then problem identify हो गया, हम लोग ने implement भी कर दिया solution. तो उसके बाद में हम लोग compare कर सकते हैं वापस Pareto बना के to identify the effect of the action taken. So this is told it will use for the prioritizing of the problem. तो इससे हमको result क्या मिलेगा? Allow classification of the important task. What is the important task? उस classification के लिए ये हमको ये tool use में आएगा. Allows identification of starting point. इधर से हमको एनालिसिस किधर से हमको सॉल्यूशन स्टार्ट करना है, इसके लिए भी ये टूल हमको यूज होगा. अलाउ प्रोजेक्शन ऑफ द इफेक्ट ऑफ द मेजर टू बी टेकन. हमको कहाँ पे ये अटैक करना है, प्रॉब्लम में कहाँ पे अटैक करना है, उसमें ये काम में आता है दिस टूल. This is the example like cause A, B, C, D, and contributing the A cause is contributing measure. So now further we can drill down to the A cause. Again, we can make the Pareto of the probable causes of root causes of the problem cause A. So it is IJK. So again, I is a major cause for occurrence or cause of A. So this way we can identify where we have to attack on the problem. And after this confirmation of effect or comparison, we can use this improved Pareto like W, X, Y, Z, and then again X, Y, Z is the measure. So W is become a lower significant problem now, as we have taken the measure on W cause or W reason of the problem. So this way we can use the Pareto diagram. Now let's move to the second. This is stratification. Also we could divide and conquer. स्ट्रेटिफिकेशन समझाने के लिए मैं इसमें जाता हूँ. उससे पहले अभी जो कोरोना वायरस कोरोड जो चल रहा है, तो हम लोग ने जो उसका डेटा अभी एवरी टाइम हम लोग जो देखते हैं कोविड-19 इंडिया ओआरजी पे, तो उसमें कैसा क्लासिफिकेशन होता है, लाइक फर्स्ट इज ए कंट्री, देन कंट्री इनटू स्टेट्स, देन स्टेट्स इनटू डिस्ट्रिक्ट्स, देन डिस्ट्रिक्ट्स इनटू सिटीज. सो दिस वे वी आर स्ट्रेटिफाइंग आवर डेटा. And then we can reach to the hotspot. Where is the hotspot in that particular city? So we can quarantine those area so the this virus cannot further spread. So this way, like in the quality, we divide the all the portion of the data into the smaller portion. So we can identify the proper problem where it is problem is occurred. Foster the understanding of situation where the problem is really occurs and where the problem is hide. So we can identify the problem with this stratification tool. The method is like XYZ. This XYZ can be operators, this can be machines, this can be product, and the number of units or number of defect occurs. This use is the observe variation among the strata. तो ये हमको एंटायर स्टेटा में क्या क्या वेरिएशन है और किधर कौन सा स्टेटा हमको इम्पोर्टेंट है प्रॉब्लम का डेफिनेशन के लिए, इधर यूज होता है. Used to identify the relationship between cause and effect, used to identify the purpose and mean to serve the purpose. The result हमको मिलेगा observing to various among the strata by performing cause and analysis the strata dia. The following can be accomplished: identify and control of a problem, diversification of the diversified data. Like as I told, we can identify the hotspot where in the Ahmedabad hotspot is there. So with this use of the stratification, we can identify these are the hotspot. So similarly in the process, like which hour, which part of the day, AM or PM. Yeah, and which shift, daytime or nighttime, which week, which month, variation among the worker, which age group of the worker, which gender worker, which year of experience, like this effect of this cause, like which is the team involved in this problem, this whether it is a newly employed or experienced employee, variation among the processing and method, working condition, temperature, pressure, speed, and everything. And measurement tool, like which tool is used, which measurement technique is used, which inspector has measured this. So we can identify the proper reason for this problem. So we can identify, we can come to the solution afterwards. Scatter diagram. Scatter diagram is used to examine the relation between two paired interrelated data. ये tool हमको use होता है where two variables is there, X and Y, such as like height and weight of the person. Height and weight is proportionate to the this each one. So we can use this tool to identify the relation between these two. Here the scatter diagram, there are four types of scatter diagrams. One is a positive scattered. The X is increase, Y is simultaneously increase. Upon the increase of X, Y is decreasing, so is a negative scatter. The combination of this both positive and negative, it could be another scatter diagram. So as I mentioned, number of relation in the X-axis and aberration on the Y-axis. This can be used to define the relationship between these two matters, and used to identify the relationship between two matters and establish countermeasure based on their cause and effect diagram. If I'll say the another example, like relationship between thermal temperature and steel material and the tensile strength. So at which temperature it is melt and what is the tensile strength? Relationship between visit made by salesman and volume of sales. So as I mentioned, and some question where came, all this tool is used in the production environment only. So no, the answer is yes. We can use it another environment also. So this can be relationship between visit made by salesperson and volume of the sales. So many a times what is happening, like due to this 7QC tool name, people is misunderstood this, these tools are related to quality, but no, these tools are related to problem solving techniques. So we can identify, we can establish the relationship between any of the problem by using these tools. Relationship between number of person visited and department store and volume of sales, and likewise. This can be identify cause and effect relationship, can understand the relationship between two results. This is used during the phases of monitoring the situation, analyze cause and relative effect of an action. So this is the third tool which we discussed. This scatter diagram is like I told, like is a positive scattered. X is increasing and simultaneously Y is also increasing. So this identify the best fit graph and it will give the best relationship between X and Y. Third diagram is a cause and effect diagram. This fourth tool, cause and effect diagram. That is also so called as a fishbone or Ishikawa diagram. Why this called is a fishbone? Because the shape of this diagram is like a bone of the fish. It so is in the main between the reason. Sorry. The cause and effect diagram is a fishbone diagram that presents a systematic presentation on the relationship between effect, result, and the factor or causes. Solving the problem in a scientific manner requires classification of the cause and effect relationship, where the effect, the result of work, varies according to factor, is a facility or machine used, method of work, worker, material, is called, sometimes is called 4M or 5M, man, machine, material, method, or environment. So which cause or which factor is affecting the defect or effect or result of the work. So we can identify the relationship between these causes and effect of the cause. This main line is called the problem line, and this is the effect of this problem, and these are the cause like related to man, machine, material, and method, and subbone is the sub-cause or sub-cause for that particular effect or the defect. So used when clarifying the cause and effect relationship, used to develop countermeasures. Here, to implement this cause and effect diagram, sometimes people use the brainstorming session. So identify or collect the data or collect the information related to process or related to effect of this problem, and then classify into man, machine, material, method, and environment. Then they identify sub-cause of this and reach to the root cause of the problem. Then the countermeasure of this root cause would be the solution of the problem. Then this countermeasure can implemented and problem can be eliminated. So this can obtain clear overall picture of the causal relationship. Sometimes we use this tool as a training purpose also. Like to give the training to employees, we can give the effect. And then the relationship between the effect, like what men can do wrong. So the effect can, what could be the effect on this system or the process. This way we can identify relationship between co-effect. Hello. Am I visible?
Yeah.
Yes.
Yeah. So cause and effect like can be used in a many copies error in the like I give the example of like wrong copying of the Xerox So like this, the machine mechanism of the copying machine, quality of copying paper, surrounding environment, and user, this main machine material method and environment. Then that can be supposed like quality of paper can be running out of stock, tool thin, folded, or damaged. And similarly, like surrounding environment is dusty, like stained, dirt on the glass surface, likewise. So this can be used anywhere in the process. Like as I mentioned, like starting from the product realization, product development to the dispatch and after sales defect and customer complaint, this kind of tools we can use. Histogram. Histogram, when we create a histogram, is a range of the data divided into smaller section. They make a uniform span and number of data contained in each section. This number of occurrence is counted in develop a frequency distribution. Then is a graph is formed in table by using PS bars, which is having highest proportional to the number of occurrence in the each section. So the histogram, if it is normal distribution, the histogram would be dialed shape. The major distribution would be on the center of the curve, and then likewise the distribution would be spread across the entire range. So we can identify where our process is running, where our center of the process is there, and then based on that we can identify the center of process and we can take the necessary corrective action in the process. This like if we measure the height of the people in the one class, so the major height in Indian like condition would be coming in the midway of 5 feet 5 inch to 5 feet 5 6 inch. So that way like entire distribution would be like 5.2 or 5.3 to 6.5 inch. So this way we can identify the range of the entire process. Yeah. And use as access to actual the condition, used to analyze the process to identify the problem point that need to be improved by finding the location or mean value of the degree of variation in the graph. Every time it is not necessary that the normal distribution curve or normal distribution will be happen. Many times like bell shape would be like seated on one side of the bell, another side bell, two centers, two processes mixed up, so two peak point would be there. So after analyzing the entire histogram data, we can identify where the process mean is there, and based on that we can identify the process, identify the situation, analyze the cause, and review the effectiveness of action. This tool result into identify the location of the mean, center, value, degree of variation, can find out the scope of the defect by interesting under value, can identify the condition of distribution, whether it is a isolated or extreme values, or it is a normal distribution. This way. Histogram like frequency, we have to identify, we have to divide entire range into smaller portions, smaller sections. Then we have to telemark how many numbers are there into each frequency zone, each zone. Then based on that, we can plot this histogram and can find out the lower limit, upper limit, mean value. Another tool like check sheet or tally sheet. This code is a basic data kept. This sheet is designed based on the objective of the data collection. So which of data we want from the process. Likewise, we can design this check sheet or tally sheet. Like I have to identify the process one, process variations like between like E10, E12, which zone they are following. So process one is following like 5 times in first zone, 2 times in second zone, 5 times in third zone, 1 time in fourth zone. The data from live process to collection of the data, we can use this tool and use when the performing thorough inspection. When we have to use the inspection, so we can identify, we can make the check sheet like that, and we can use this to monitor the situation, analyze the cause, and review the effectiveness of action. We can use this afterwards. So after taking some corrective action, we can again use this checklist to whether our corrective action is effective or not, to analyze the result further on. Ensure the collection of required data, allows the through inspection or check item, can understand tendency and variation, can record required data. this check sheet kind of this like various vertical sketches, like if we are to identify this defect in one particular set of product, one batch of the product, like vertical scratches, how many part is having the vertical scratches, how many part is having the scratches, how many part is the dent, this first batch, second batch, third batch, fourth batch, fifth batch, sixth batch, and likewise. So I can identify the data based on the batch wise. I can get the data in this fashion. So I can come to the solution that like major source of variation or major defect is vertical sketch in all the batches, and in out of this batch number 1 and batch number 5 is having the major defect found in the vertical scratches. So further I can drill down to, and I can go to the batch 1 data by using another tool, and then I can prioritize the defect. I can come to the defect point, and I can come to the source of the variation or source of the defect, and then I can identify the real root cause. So we can eliminate that root cause. This tool is a control chart. The control chart is used to examine the process to see if it is stable or maintain the stability of the process. This method is often used to analyze the process. To do, the chart is created for the data collection for a created period of time, and dot plotted on the chart are extremely how they are distributed, and they are established in control limit. After the action are take control and standardize variation factor, the method is also examined in the process stabilize the action, and is to keep the processor stable or not. Here, the control chart, people many a time only see that like control chart is only X bar R chart, but it is not like that. There are many other charts are there. For the variable data, the charts like X bar R chart, X bar S chart is a standard X bar and standard deviation chart. Moving average chart is IX chart. And for the attribute data is a P chart and NP chart. P chart is for fraction defect, and NP chart is used for numeric defect for the sample. C chart for defect per sample, and U chart defect per unit. So these are many kind of control charts we can use. This tool is used for software people, like basic software people can monitor the process. The process should not be go beyond the control limits. So they can plot the chart, and they can identify the process, that process is not going out of the control. And this chart can be used at managerial level also. How we can use this at a managerial level? The managerial level, we can see the
one minute. Yeah. Sorry for the interruption, but like in 1 minute, so the Zoom has this 40-minute limit. So this is an announcement. In 1 minute, we all have to rejoin it again, just to start from where we have left, and then we can take the question answer and all that. So in 1 minute, we have to rejoin again. And there's one request, ke Zoom ma je dummy jena names che, maybe your mobile name or the numbering, just keep your original name for security purpose. Okay, thank you.
Name as well as, I would suggest, if the video is not on, there should be a profile picture coming. People can do the profile settings and set up their picture.
Yeah.
And also I request you can use the chat box, and you can give your name, number, and chart we